Good morning. It's February 16th, and this is your daily brief in science. Here's everything you need to know. New Orleans Mardi Gras is moving away from traditional plastic bead throws by adopting plant me beads made from polylactic acid that include seeds from okra for planting after the parade. Louisiana State University produced 3,000 plant me bead necklaces for the 2026 season and gave them to 3 crews to gather feedback on reception and practicality. The project grew from algae-based bioplastics being too costly, with plant me emerging from 3D printing work led by Louisiana State University biologist Naohiro Kato and graduate student Alexis Strain. The effort is supported by funding and collaboration aimed at reducing waste and creating educational opportunities in bioplastics and plant biology. Louisiana State University's lab is partnering with local schools to promote environmental education through bead making, weaving sustainability into Mardi Gras culture. Cato envisions engaging schools in bead making to educate about bioplastics and plant biology while pursuing faster degrading materials and commercialization pathways for algae-based plastics. The researchers see potential for broader education and community involvement, including school collaborations to teach bioplastics and plant biology, and exploring faster degrading materials beyond PLA that still allow planting. Cato also envisions community 3D printing projects in schools to educate students about bioplastics and plant biology, while pursuing commercially viable algae-based plastics. Crew of Freret leaders note a cultural shift toward items that spectators value and will keep, helping reduce litter and environmental impact during Carnival. Ongoing research assesses microplastics in the lake and evaluates the environmental impact of bead alternatives, aided by new grants to the Conservancy. Organizers emphasize reducing waste and shifting culture toward eco-friendly memorabilia of lasting value beyond the Carnival season. The initiative seeks to redefine Mardi Gras keepsakes as environmentally friendly mementos while expanding bioplastic commercialization and community beadmaking and education opportunities. Lake Suwa's Miwatari, the so-called God's Crossing, has long served as a climate register, with priests recording ice temperature and thickness since the 15th century. This year, 2024 to 2025 observations mark an 8-year drought in crossing events, tying the longest gap on record and linking the trend to warming and thinner, shorter-lived freezes. Scientists explain that Miwatari form when the lake freezes solid for several days below -10 degrees Celsius, prompting the ice lid to expand and crack into ridges that thunder as they shift. Warming has reduced the frequency of this emission of ice noise. Priest Kiyoshi Miyasaka notes the deep personal and cultural value of preserving the tradition and the climate data for future generations, aiming to pass the message to people a century from now. Officials frame recurring gaps as indicators of warming, warning that continued temperature rise could erase the crossing entirely in the future. Despite the absence, Miyasaka remains committed to documenting seasons as records for future generations and viewing the trend as evidence of climate change impacts. The 2026 watch is led by Miyasaka, with geographer Naoko Hasegawa and emeritus professor Takehiko Mikami interpreting the event and its links to climate change. The article underscores the cultural importance of the ritual and its role in environmental monitoring, while noting uncertainty in long-term forecasts. When a crossing does occur, it is accompanied by a Shinto ice ritual performed by the shrine priest, an event that has happened only a few times in recent decades. A brief full freeze on January 26 gave way to melting, and by February 4 observers declared an open sea, signaling slim chances of a crossing that season. Even partial freezes can fail to produce a crossing, contributing to a broader pattern of longer gaps or absences in Miwatari. A multinational team maps venomous scorpion hotspots beyond Morocco using maximum entropy modeling layered with field observations and global soil, temperature, and habitat data. The goal is to identify where risks are highest, including tropical regions with sparse records. The study, a collaboration between University of Galway and University Ibn Zor in Morocco, emphasizes translating ecological insights into public health tools for antivenom development and rapid diagnostics. Researchers advocate multidisciplinary collaboration among ecologists, clinicians, public health experts, and local communities to improve diagnostic tools and therapies, especially in resource-limited settings. They envision using the mapping approach to guide actions such as targeted awareness campaigns, frontline clinician training, and prevention efforts in high-risk areas from Brazil to the Middle East and India. The work stresses protecting children and informing region-specific prevention and education efforts to bolster global public health responses. Dr. Michel Dugan highlights pinpointing high-risk areas to help health authorities target awareness campaigns and shield vulnerable populations across diverse regions. First author Fuad Salih notes biodiversity data can inform public health policy, and combining long-term fieldwork with ecological modeling can generate real-world impact for Morocco and beyond. The findings show pronounced ecological heterogeneity, with some species having broad habitat tolerance and others being narrowly distributed, signaling region-specific risk patterns and resource needs. The study argues for moving from reactive to proactive public health responses by predictive mapping to allocate resources efficiently and reduce envenomation-related morbidity and mortality. Overall, the work aims to repurpose ecological insights into scalable device-agnostic applications across continents to address tropical data gaps and inform interventions from the Americas to Asia. Globally, scorpion stings affect over 2 million people annually, with more than 3,000 child deaths, underscoring the public health importance of better identifying risk areas and improving care. While thousands of scorpion species exist, only about 100 of over 2,000 are potentially lethal, yet stings remain a major health issue with tens of thousands of injuries and thousands of child fatalities each year. A new review from Karolinska Institute and collaborators surveys perioperative immunotherapy across 7 cancer types to see how starting treatment before or after surgery is reshaping cancer care. The Journal of Internal Medicine synthesis covers skin, lung, breast, gastrointestinal, gynecological, head and neck, and urological cancers to map evolving neoadjuvant and adjuvant strategies. It emphasizes perioperative immunotherapy as a shared approach across cancers, looking at both preoperative and postoperative windows and the possibility of combining strategies across these timeframes. The review notes challenges including treatment side effects, the risk of overtreatment if surgery alone would suffice, and balancing costs and healthcare resource use. The accompanying publication discloses funding sources and potential conflicts of interest. A key aim is to identify biomarkers that predict benefit, with calls for more research on optimal use, safety, and cost considerations. Researchers stress weighing costs, side effects, and resource implications when applying immunotherapy earlier in disease. There is a strong push to determine which patients will benefit across tumor types and to clarify best perioperative approaches through further studies. Results vary by cancer type, with challenges including potential side effects, overtreatment risk, and uncertainty about costs and resource demands when applying treatment earlier. Adjuvant immunotherapy can reduce recurrence risk after surgery, and neoadjuvant immunotherapy may enhance immune recognition while the tumor is still intact, with some cases benefiting from combining both approaches. Some cancers may benefit from both neoadjuvant and adjuvant immunotherapy, though outcomes differ by cancer type. Overall, immunotherapy is being introduced earlier in treatment and shows potential benefits across multiple cancer types. A new wave in cancer care is shaping up as a collaborative, preventative, and personalized approach that knots together genetics, survivorship psychology, environmental health, and cross-disciplinary infrastructure. In February 2026, Genes in Development highlights a paradigm shift, with ongoing projects like the SMART-3 RP lymphoma study and the Kenneth C. Griffin Cancer Research Building's grand opening signaling a push toward real-time data sharing and rapid bench-to-bedside translation. The SMART-3 RP lymphoma study provides survivors with a standardized toolkit to improve long-term quality of life within 2 years post-treatment, treating resilience as a developable skill rooted in behavioral medicine. Researchers describe resilience as something that can be built, not just hoped for, aiming to support long-term well-being through standardized coping tools after therapy. The Griffin Building is designed to break down research silos, positioning Miami as a global hub for medical research and related tourism through open, integrated facilities and robotic screening. Sylvester Comprehensive Cancer Center reports a breakthrough in chemotherapy resistance by blocking a regulatory protein that induces transcriptional stress, restoring chemosensitivity in resistant cancer cells, as detailed in Genes and Development. This work frames transcriptional stress as a mechanism to sensitize cancer cells to DNA-damaging chemotherapy, advancing synthetic lethality and precision oncology. The publication explains that inhibiting specific proteins removes cellular breaks, triggering transcriptional stress and making cancer cells more vulnerable to chemotherapy, illustrating synthetic lethality in action. There is a clear shift toward patient-centered research, prioritizing patient-reported outcomes alongside clinical results, exemplified by Dr. Frank Pinedo's trial, enrolling 250 patients to teach coping strategies. Dr. Shreya Kumar leads GI oncology work focused on prevention, eradicating Helicobacter pylori and addressing early-onset colon cancer, while highlighting disparities and the need for targeted screening. The GI effort emphasizes prevention and disparities, including Helicobacter pylori eradication to prevent stomach cancer and targeted screening for early-onset colon cancer. The Griffin Building opens as a 12-story integrated facility designed to speed translation by housing researchers, clinicians, and wellness spaces in close proximity, fostering research neighborhoods and real-time data sharing to accelerate discoveries. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.